Problem number 65 asks us to factor this two-term expression, a times this y minus 2 plus z times the y minus 2. Now, it may look a little bit more complicated than the other ones we've done, but it's the same idea. What's common to both these terms? Well, it's pretty clear here. You can see this y minus 2 here and a y minus 2 here. So we've got that y minus 2 in both of those terms, so let's take that out. And because there's more than one term, we need to use parentheses, right? There's more than one term, so it's just got a longer name, so we'll use parentheses to capture all of it. And then if we take that y minus 2 out, what's left? Well, look at this. We've got a times y minus 2. If we take that y minus 2 out, what's left over here is the a. And if we take it out from here, we're left with this plus z. So let's write our plus z here. And that's it. So we've got that y minus 2 common to both, and if we take it out, what's left is this a plus the z. Problem number 69 asks us to factor this two-term expression. Now you can see what's common here is that m minus 2. So we're going to be taking out that m minus 2, and if we do, now again I'm going to use parentheses because there's more than one term, so I have to capture all of it. So I'll take out that m minus 2, and what's left? Well, in the first term, if you take out that m minus 2, what's left is that n squared. So I'll have n squared. And over in this last term, if you take out that m minus 2, what's left is that plus 1. And there's our factored form. So we'll claim that it is now factored. Let's take this problem just one step further. Now, the problem does not ask us to do this, but let's just explore this idea here. What happens here is that, here you've got plus 1 times n minus 2. Now, it's likely that we don't really write multiplications by 1, so it's reasonable that we could see this problem look like this. N squared m minus 2 plus, and then 1 times n minus 2 is just m minus 2. Now what you have to do is you have to see that there's an m minus 2 here and an m minus 2 here. And you just see this one as one thing. So you see this, but what you're visualizing in your head is this. N squared m minus 2 plus m minus 2. See it as one thing, so I'll put the parentheses around there. And then you notice that you have just one of these. So what you're really looking at is this plus one of those. And then this problem here, when you see it like this, really is this problem up here. In problem number 71, we've got two terms again, and it's pretty clear that what's common is this 8t plus 5. So what we're going to do is, of course, we'll take out that 8t plus 5. And if we remove the 8t plus 5, right, look at this one. If you remove it, what's left is just that 2. So here's what's left, the 2, and then plus. Now, over here, if we remove the 8t plus 5, what's left is that x. So it's just 2 plus x. And then we will claim that that is the factored form. Okay, now in problem number 81, we're given these four terms, and as I look through it, I don't see anything common to all four. There's an A, and an A, but no A here. There's a B, but no B's here. Okay, I'm just looking at the problem again to make sure I wrote it right, which I did. Okay, so here's what we're going to do. Kind of an alert here. If there's four terms, or anyway, an even number of terms, typically 4, because that's the way these problems are written. If there's 4 terms and nothing common all the way through, I'm going to try what's called grouping. So notice that if we do this, if we group together these first two, I see an A here. There's an A common to those first two. And if I group together the second two, I see that there's a B common to those second two. Now, I'll go just a little bit further here. In this group here, the first term is positive. So really, I'm thinking of a positive A here. In these two terms, the first term in this group is positive. So I'm thinking of a positive B here. So what I'm going to do is I'm going to take out a positive A here. So let's do that. Take out a positive A out of these first two. So just take an A out of here. There was 2 A's to begin with. If we remove one of them, we're left with 1A. And over here, negative 7a, if I remove the a, I'm left with that minus 7. And now over here, I'm going to take out a plus b, right? The first term in the group is positive, so I'm going to take out a plus b, and then if I do that, what's left is this. In ab, if I remove the b, what's left is that a, so there's an a left. And then over here, negative 7b, minus 7b, if I remove the b, what's left is that minus 7. So minus 7. And now what we see is this. That a minus 7 is common to both of these terms. So that a minus 7 is here and here. So let's take it out. So we'll have an a minus 7. And again, parentheses, because there's more than one term. And then if you remove that a minus 7 in the first term, there's an a left. And if you remove it over here, there's a plus b left. And there is our factored form. So we'll claim that that is now factored. This is called factoring by grouping.